This lesson is on classifying quadrilaterals. We're moving into a new term, new unit, working on quadrilaterals. So let's review about triangles. First off, a polygon is just a multi-sided figure, and a triangle actually is a multi-sided figure. It has three sides. One of the things we know is that the sum of the angles equals 180 degrees. So if we're trying to find a missing angle, we could set up an equation: x plus 88 plus 52 is equal to 180 degrees. And if I added 88 and 52 together, I would get 140 equals 180. And then to find x, I just solve for x. X is 40 degrees. That's what we know about triangles. We're going to use some of that information and some of those same techniques as we are going through this lesson. This is something you want to write in your notes. Take a picture of it, write it down, make notes of it. We're going to go through these individually, but these are the types of quadrilaterals we're going to be talking about. First off, we have a quadrilateral that's any four-sided figure. They're broken into three groups, a trapezoid, parallelograms, and kites. And then parallelograms have more specific groups, and then we get more specific. So as we move down our chart like this, we get more and more specific. And we'll be talking about each of these individually. So let's start with the first top. Here we have a quadrilateral, and there are three types of quadrilaterals. We have trapezoids. A trapezoid, remember these marks mean they're parallel. It has exactly one pair of parallel opposite sides. Only one pair of sides is parallel. It can be drawn this way or this way, but you'll notice that only one side or one pair of opposite sides is parallel. That's a trapezoid. A parallelogram, you'll notice, has both opposite sides are parallel. Both pairs of opposite sides are parallel. So that's a parallelogram. And we can have lots of different forms of parallelogram, but if both pairs of opposite sides are parallel, it's a parallelogram. And finally, a kite is determined by side length. And the way we do this is we have two adjacent sides. So this side and this side, they're adjacent, they're next to each other. They are congruent. And the opposite two sides are also congruent. But you'll notice because these are not congruent to each other. So this set is congruent and this set is congruent, but those two are not congruent. So that makes a kite. So let's take a look at this. Which describes the pedestrian crossing sign? Well, we notice we have parallel line markings on opposite sides. So which one has both pairs of opposite sides parallel? Well, we know it's a parallelogram. So we have this one says parallelogram and this one says parallelogram. So which one is it? Why? This one says both pairs of opposite sides are parallel, and this says one pair of opposite sides is parallel. Well, in order to be a parallelogram, we know that it has to have both pairs of opposite sides parallel. So that's the reason that this is a parallelogram. Now let's get a little bit more specific. Remember, we talked about how as we move down our chart, we get more specific. So quadrilaterals, any four-sided figures. Then we have trapezoids, parallelograms, and kites. Well, within the parallelogram family, we have two more specific types of parallelograms. We have rectangles. It has four right angles. That's what we know those mean right angles. So the opposite sides are parallel still because it's a parallelogram, but it also has four right angles. A rhombus, we're dealing with side length. And a rhombus, you'll notice all these marks, they are all congruent. So it's a parallelogram because opposite sides are parallel, but all sides are congruent, so it is a rhombus. And then finally, we have squares. Squares are parallelograms that are also rectangles and also rhombi. Rhombi is plural, so a square is also a rhombus because it has four right angles, just like a rectangle. It has four congruent sides, just like a rhombus, and we know both of those are parallelograms. So that is kind of if you want to write this down in your notes on that other diagram so you know what identifies each one. What are the identifying features of each of the different kinds of quadrilaterals? So let's take a look at this. Understanding the classification. So we're going to write always, sometimes, or never for these statements. A square is it always a parallelogram, sometimes a parallelogram, or never a parallelogram? Well, we can look underneath here, and it falls underneath this parallelogram umbrella, so it is going to always be a parallelogram. What about a rectangle? Is a rectangle ever a trapezoid? No, because it's part of the parallelogram family, so it cannot be part of the trapezoids. Never a trapezoid. How about a rhombus? A rhombus can be a square, but is a rhombus always a square? Not always, sometimes. A square is always a rhombus, but notice this rhombus up here isn't a square, so a rhombus is sometimes a square. And finally, a quadrilateral, which is our top category. Is it always a kite, sometimes a kite, or never a kite? Well, a quadrilateral, or a kite is a quadrilateral, but a quadrilateral can also be other things, so it is sometimes a kite. Here's a proof that's in your instruction. I just want to walk through this to make sure we understand everything that we're talking about here. Basically, we've got a parallelogram here, and we want to prove that the sum of the four sides is equal to 360 degrees. So if we say ABCD is a parallelogram, then we know DC and AB are parallel to each other. Those are parallel lines. And then I'm going to call this a transversal. Okay, so AD and BC and AB, and these are also parallel. I guess I should do that. They're parallel lines. So we're going to use AD as a transversal. What does that tell us about angle A, and which angle are same side and interior angles? So here's A, here's our parallel lines. D is our angle that is the same side and interior of those parallel lines. And what do we know about same side interior angles? We know that they are supplementary. And by definition of supplementary, they have to add up to equal 180 degrees. That's what supplementary means. So now we're going to use a different side as the transversal. Now we've got to choose a different side that shows B and C are same side interior angles. So here's B and here's C. Well, they are on the same side of this transversal right here between the parallel lines. So in this case, we're going to use BC as a transversal to show that B and C are same side interior angles, which are also supplementary, which also add up to equal 180 degrees. So we can add those two sides together. Measure of angle A, measure of angle D, BC equals 180. Which property is that? Addition, subtraction, substitution, or transitive property? Well, we're just adding them together, so that's just our addition property. And then we can simplify to equal 360 degrees. I didn't tell you, these were the options for this one up here. Complementary, congruent, or supplementary. We found out it was supplementary. So that walks you through the proof. Based on that proof and other ways, we know we can find out that this is a theorem, quadrilateral angle sum theorem. The sum of the angle measures is always 360 degrees. Doesn't matter the quadrilateral, if it's a rectangle, if it's a trapezoid, if it's a kite, it does not matter. The sum of all of the angles are going to add up to equal 360 degrees. So if we take a look at this problem right here, we have a recycle bin, and we want to know what our missing angle is right here. What is our missing angle? Well, we can say, I'm going to call that angle X. We can say that X plus 72 plus 108 plus 108 is equal to 360 degrees, because that's the sum, our quadrilateral. So I'm just going to add these up real quick. So if I put in 72 plus 108 plus 108, I get 288. So I know X plus 288 equals 360, and then I just subtract 288 from both sides, and I find out X is equal to 72 degrees right there. So I want you to pause the video and try this one on your own using that same method we just talked about. Okay, check your work. You should have got 52. The other thing you can do is if you have three angles, you can just say 360 minus 128 minus 126 minus 54, and whatever's left is the same thing. That's working out. You don't have to add those all together first. So which statements are true? I want you to select all that apply. So we're trying to look at, this is classifying these. So I want to pull up my little form that I hope you have in your notes, and if you don't, now's a good time to put it in. So what are we talking about? So which are true? A square is sometimes a rhombus. Well, square is below the rhombus. That means it's always a rhombus, not just sometimes. So that one is not true. A rectangle is sometimes a square. Well, that is true because a rectangle can be a square, but it also can be not have congruent sides and just be a rectangle. So a rectangle is sometimes a square. A parallelogram is sometimes a kite. Kites and parallelograms do not fall underneath one another, so they are never going to be that. So that's not true. Sometimes kite. A square is always a rhombus. A square falls underneath the rhombus, so a square is always a rhombus because a rhombus means opposite sides are parallel and congruent sides, and a square always has opposite sides parallel and congruent sides. So that one is true. And a trapezoid is never a kite. If they are on the same level, then they do not fall underneath one another, so a trapezoid will never be a kite. That is also true. So let's take a look at this. Which best describes the structure outlined in the bridge? Well, you notice we have parallel lines. We have one set of parallel lines. That's all we know. So if we have exactly one pair of parallel lines, we know that it has to be a trapezoid. So that's going to be this one or this one. It's not a parallelogram. They have to have both pairs of opposite sides. So it's a trapezoid because it has exactly one pair of opposite sides that is congruent or that is parallel. Well, they're not congruent. They're not the same side. They are parallel. So that is the correct answer. It's a trapezoid because one set of opposite sides is parallel. So if this is a square, what are the values of t and f? Well, what do we know about all these angles in a square? They're 90 degrees, right? So we're just going to have to set up 4t plus 20 is equal to 90, and 7f plus 6 is equal to 90. So pause the video and see if you can solve for those. All right, once we just solve, we get 17.5 for t and 12 for f. So if a carpenter is framing an opening in a wall to hang a rectangular door, so what do we know about rectangular doors? So he's got to have a rectangular door and he's going to frame the opening. We know we're going to have right angles, and we know the opposite sides are parallel to each other. That's what we know about rectangles. So let's take a look. Top and bottom are parallel. Yes, that needs to be true. The top and the right side form a right angle. Yeah, that needs to be true. The bottom and the right side are congruent. Well, do we need to have this congruent to this side, congruent to this side? No, that's not necessarily true. The left side, this side and this side, are they parallel? Yes, those are parallel, so that needs to be true. And the left side and bottom need to form a right angle. Yes, that is also true. So those are the things we know about rectangles. What is the value of S and the length of side BC? Remember a rhombus. What do we know about rhombus? They have congruent sides. So we know that all four sides are congruent. So see if you can pause and set this up and solve this one. All right, pause the video and see how you did on this one. We just set those two sides equal to each other and solve for S. We get 45, and then we can just substitute 45 back into AB, and we get 434. Let's look at this one. A community swimming pool is in the shape of a rhombus. What do we know about a rhombus? We know a rhombus is a parallelogram with, that doesn't look like a very good rhombus. All sides are congruent and opposite sides are parallel. That's what we know. So let's look at that. Is it a parallelogram? Well, both sets of opposite sides are parallel. That is true. It is a square. Not necessarily. If it's a rhombus, we don't know anything about the angles. We just know about the sides. Is it a quadrilateral? Yes, it falls within our quadrilateral. Remember our thing, if it's a rhombus, it's also a quadrilateral. As we go up the ladder, they are always true. Is a rhombus a rectangle? Well, we can look at that. Is a rhombus a rectangle? No, they're on the same level, so they're not. And it does not fall underneath a kite, so that is not true either. Okay, take a look at this. What are the side lengths? Look at what we know. This is a kite. What do we know about? So pause the video and see if you can solve for these values. Because it's a kite, we can set these two equal, solve for y, and then substitute back in to find kn. And same thing with x. Set those two equal and substitute back in and solve for. So on this one, what is the greatest angle measure in the diagram? Well, the first thing we need to do is we need to set them equal and solve for x. So pause the video and try this one. So if I solve for x, I get x equals 7. Now, which is the greatest angle? Well, I can look at this, and this is my biggest angle. I can tell that's an obtuse angle. So I take 15 times 7 plus 14, and I'm going to get 119 degrees. Okay, pause the video and see if you can solve for x in this one. You should get x equals 4. Pause the video and try these two problems and then come back and check. Because these sides are congruent, AD is 22. In this case, we have to set this up. We know supplementary angles equal 180. We can solve for x, and then we can follow through and find out all the rest of those angles based on what we know about parallelograms.